Good morning. Thank you for joining us this morning. Today we're going to talk about the new OSHA rule for crystalline silica exposure. My name is Eric Petorsky. I'm the National Sales Manager with Ruwac Industrial Vacuums. We're a worldwide manufacturer of industrial vacuums for many markets, including the concrete industry, where we specialize in vacuums for fine dust. What's the reason for the OSHA ruling? Well, previously permissible exposure limits were formulas that many found to be hard to understand. The construction of shipyards, the PELs were obsolete particle count limits. So we're dealing with a standard that's very old, and it was something that allowed too much dust to be airborne. For example, general industry, the permissible exposure limit was about equal to 100 micrograms per cubic meter. And for the construction and shipyard industry, that was 250 micrograms. So those are much higher than the new standard applied for. Most important reason for the rule: the previous limits did not adequately protect workers. Previously, the limits were more than 40 to 45 years old. So they hadn't revisited this for a long time, and the levels just didn't apply anymore. You know, if you look at the tools we're using today, the tools produce a much finer profile on concrete, and therefore the dust is finer. So as the tools got more advanced and the finishes got more advanced, the standards did not. So there is evidence that there is definitely caused cancer from silicosis, and that's at anything under the 100 micrograms per cubic meters. And if you look at the shipyards and construction industry, they were 250 was a permissible limit. So the days of blowing dust around really do have to stop in order to protect people's health. And it's not just people doing the task, it's the people that may not be doing the task. People driving down the road, walking down the road, or in a factory just visiting, and there's dust cloud coming. So it is time to reduce that. So the exposure and health risks. Well, exposure to the respiratory crystalline silica has been linked to silicosis, lung cancer, chronic obstructive pulmonary disease, and kidney disease. If you take a look here, there's a healthy lung and there's a silicotic lung. It is something that definitely has to be taken into consideration in order to prevent more deaths. So if you take a look here, OSHA reports more than 900 new silicosis cases per year combined between construction and general industry. Now, understanding that silicosis isn't an immediate thing, that's 900 new right now, but as we have more and more people working with concrete, we expect that number to increase drastically. OSHA estimates that once the effects of the rule are fully realized, it will prevent more than 600 deaths per year, 124 lung cancer, 325 silicosis and non-cancer related, and end-stage kidney disease 193. So what industries are affected? Well, we have just about anything. Silica is all around us. Silica is used obviously in the surface preparation world, where we are reforming or resurfacing concrete, but it's also used in places like dental laboratories and structural clay products. It could be pottery. It could be your smaller areas. It can be larger companies like foundries that are doing sand casting. As you know, there's silica is an additive in many products, including glass and also the computer chip industry. So there's silicosis in the need to look at industry as well as the construction industry is great. Workers affected. There's 2.3 million workers affected or possibly affected, and 2 million of them in the construction industry, and 300,000 are going to be in the maritime or the general industry. So there's an idea of how many people are in the construction related industry that are going to be risks to silicosis. They estimate 676,000 establishments, and 600 of them in the construction industry, and 76,000 in the general industry and the maritime. So what is respiratory crystalline silica? Respiratory crystalline silica is a very small particle, typically at least 100 times smaller than your ordinary beach or playground sand. So if you think about that, if you look at the sand that's at a beach, it's 100 times smaller than that. So it's the dust that can become airborne, get into your lungs, and not leave. How is it generated? Well, it's generated from cutting, sawing, grinding, drilling, crushing, any kind of stone or rock or concrete, creating that smoke-like dust when you're trying to alter the form of the silica. So when you pulverize that either by a saw blade or a drill or jackhammer and it creates that fine smoke-like dust, that is the dust that we are indeed talking about. Specific activities, again, blasting, sawing, cutting, jackhammering, grinding, anything that creates airborne dust. So let's talk a little bit about the new standard. There was no change that has been implemented in the last 45 years. The new rule applies to any situation where the particle exposure limit is above 25 micrograms per cubic meter. So if you have if you have an area that's 20 over time weight average, 25 micrograms per cubic meter, then you must take action to keep the exposure below 50 micrograms per cubic meter over an 8-hour time weight average. And just a little bit you're going to see through this the definitions. PEL, particle exposure limits. UG per meter cubed is micrograms per cubic meter of air. TWA, time weight average. HEPA, high efficiency particulate air. That's a type of filtration. 99.97 at 0.3 microns is the efficiency of a HEPA filter. PLHCP, physician or licensed health care professional. APF is assigned protection factor. That's what you're going to see on all the tables talking about your respirators. So the rule went into law June 23rd, 2016. So it went into law quickly after it was published in March, and then it must be in compliance by September 23rd, 2017. Now just understand this presentation. It does not qualify as the law. You have to just understand we're giving you an overview of this particular section. We're using a lot of the OSHA documentation that we've compiled. It's hard to fit it all into an hour, so we're going to go quickly. If we miss something, it's not intentional. And if you have specific questions, you can address them afterwards. Send us an email or give us a phone call. We'll address them. So we are going to try to go through this as quickly as possible and cover everything we possibly can. But if we miss something that was important to you, please understand that was not intentional. So, Respiratory Silica Standard. OSHA introduced 2 new standards for silica. One is for general industry, and that includes maritime industry, and then the other is for the construction industry. The effective date for both is June 23rd, 2016. Which one requires action? Well, the construction one they're actually putting into law first, where they're going to start monitoring this on September 23rd. So you need to be in full compliance for anything in the construction-related industry by September 23rd. For the general industry, you have until June 23rd of 2018. And a lot of people are asking, why did they have the construction one first? Well, for decades they've been doing testing and data, and they understand the tools being used, and because of that, the document was written in such a way that being in compliance would be a little bit more easier than a general industry, which general industry, not all 2 applications are the same. So it's harder to regulate that. But on the construction, they did do a nice job laying out what is going to be required for your specific application. So they feel that you can be in compliance much faster because a lot of people have already been doing as much as they possibly can to control the dust. So construction versus general industry standards. What's the difference between construction and general industry and the maritime standards? And OSHA recognized the construction industry has some unique challenges to help employers to keep all work safe. OSHA has issued 2 standards: construction job site change. So OSHA focused on a specific application and use of equipment that are common in that construction industries. And then silica exposure is extremely common in the construction industry, highlighting the need to protect the workers. Construction industry must be in compliance sooner than general industry for some requirements. OSHA estimated that exposure levels for specific applications and the use of equipment making it easier to select the right respirator. OSHA's prescribed engineering controls must be in place. Baseline and follow-up medical exams are required for all workers to wear respirators 30 days or more annually. So basically what this is saying is, again, the construction industry, they know a lot about it, they know a lot about the application, the tools being used, and therefore they could publish a document that said, hey, if you follow these written exposure control plans and you follow these protective measures using this equipment, we know you're going to be in compliance. Therefore, we can get this out the door quicker. The OSHA rule requirement. The first step for an employer is to determine if the standard applies to his work. If the work is covered by a standard, an employer has two options for limiting employee exposure. You can use specified exposure control methods, which is Table 1. I'm sure a lot of you have heard about Table 1 or heard this Table 1. Well, that's what we're going to discuss today is Table 1. We're going to try to open up your eyes and see what's going inside of there, because it's really not as complicated as a lot of people think, and it really is a nice outline to follow for your general tools, which are most of them. If something you have does not fall into Table 1, then we have alternative exposure control methods. So employers who choose the specified exposure control option must fully and properly implement protections for the task or equipment listed in Table 1 of the standard. So if you're going to choose that option, you got to listen to Table 1 and you got to do it. Employers who fully and properly implement the controls in Table 1 do not have to assess employee silica exposure levels or keep employee exposures at or below the permissible exposure limit. That's probably the most important part right there. If you're going to follow Table 1 and you're doing everything it tells you to do and you're doing it properly and everybody's properly trained, then you do not have to assess employee silica exposure levels or keep the employee exposures at or below permissible levels. It does state in the OSHA guideline that if you are following Table 1, and I'm taking this right out of the small entity guide from those of you that are following along, it's on page 6, it does say if you are fully and properly implementing Table 1, a small amount of dust can be expected from the equipment that is operating as attended by the manufacturer. However, noticeable increase in the dust generation during the task is a sign that dust controls are not operating correctly. So it's understandable you're going to have some dust. They understand you're going to have some dust, they being OSHA, and if you're following Table 1, you just need to know what is some dust versus what is too much dust. And then we'll go back. Employers that conduct tasks not listed in Table 1, so you fall outside of anything that's published, or do not fully implement the engineering controls, work practices, or respiratory protection, you just decide not to follow Table 1, then you must follow the alternative exposure control methods approach. So two options, Table 1 or go alternative exposure. If you go Table 1, you don't have to do any air sampling, air monitoring, and you just have to follow and do what Table 1 says. So let's just focus on some key highlights here of the standard. We're going to talk about exposure assessment, engineering and work practice controls, specific exposure control methods for various applications and equipment that are used in the construction industry. Employer must implement a written exposure control plan. Medical surveillance and medical exam of all affected employees must be initiated if the exposure is or at above the action level. We're going to talk about medical as well. Respiratory protection is required. That's clearly defined in Table 1. Specific hazard communication requirements and the specific training requirements in addition to training requirements as part of the respiratory protection program. So let's talk about our compliance options one more time. We have Table 1. The Table 1 option is going to be the easiest for most companies to be compliant. The tables list several tasks and give specific direction to reduce silica exposure, including engineering controls, practices, and required safety equipment. The alternative exposure control plan for tasks not listed in Table 1 or where Table 1 engineering exposure controls are not practical or available to use, this method of compliance requires more stringent practices. These practices are going to include mandatory exposure air monitoring. And when you do the air monitoring, you have two ways to do it. You have performance option, and then you have scheduled monitoring. Then we have mandatory medical surveillance and mandatory record keeping. Now it's important to understand, regardless if you take Table 1 or you fall outside of Table 1 or decide not to go with Table 1 and use the alternative exposure controls, you need to do medical surveillance and you need to do record keeping on both. So that's something that is going to be required. The only thing really different is going to be that you don't have to do the air sampling. So Table 1 entries. These were taken out of the small entity guide. These are the Table 1 entries. You have walk-behind saws, handheld grinders for mortar cement, handheld grinders for others use than mortar removal. Important to understand those are two different things because their requirements are different, especially when it comes to respiratory protection. If you're doing tuck pointing or mortar cement, your respiratory protection is going to be different than if you're using it for other than mortar cement. So sometimes they may seem like similar applications when you're reading through these tables, but try to make sure when you look at the table that you define exactly what you're doing, that you did pick the right table for the right tool. Even though that tool might have two different applications to it, make sure you know the task at hand for the tool that you're using and you pick the right one. Walk behind milling machines and floor grinders. Jackhammer power chipping equipment, there's one that creates a lot of dust. Nobody's ever done anything about it, so the jackhammer industry, that's something that you really want to take a look at. Heavy equipment, utility vehicles. So here we get into some of the non-surface preparation related equipment, but still in the silica area. So you have heavy equipment, utility vehicles. Then you have your handheld stand-mounted drills, vehicle-mounted drills, crushing machines, milling machines, both large and small, stationary masonry saws, handheld power saws, drivable saws. So we've got walk-behind saws, handheld, drivable, all with something a little different. So if you have a saw, don't just go to your first saw table one. Make sure you narrow it down to which one is what you need to be following. So here are the compliance options. Here's your roadmap. This is taken right out of the small entity guide, and it basically reiterates what we just said. It says A, or number one, determine if the silica applies to you. If it doesn't, then move on. If it does, then you need to choose between table 1 or the alternative method of compliance. And here's a chart here that says on the in the middle column, it says if fully and properly implementing table 1, what I have to do. Well, PEL, do we have to do that? No. Exposure assessment, nope, don't need to do that as well. And methods of compliance, we do not need to do that. Now, respiratory protection, you'll notice for both, yes, it's required. Housekeeping, yes. Written exposure control plan, medical surveillance, communications of hazards, and record keeping, yes for all of them. So today, those are what we're going to focus on. Methods of compliance, respiratory protection, housekeeping, written exposure control plan, medical surveillance, communication of hazards, and record keeping. And just so you understand, communications of hazards is basically training. How are you letting everybody know that there's a hazard? So we're going to call that training. So let's talk about this written exposure control plan. Probably one of the most important things that's going to be required that hasn't been required before. It is a description of all tasks performed that involve exposure to crystalline silica. A description of the engineering controls, work practices, and respiratory protection used to limit employee exposure to respiratory silica for each task. A description of the housekeeping measures used to limit employee exposure to the silica. A description of the procedures used to restrict access to work areas when necessary to minimize the number of employees exposed to silica. So let's just take a look real quick. This written exposure plan is now getting us to outline and define what we're doing. It's a description of the engineering controls, the work practices, to limit the exposure. So it's going to say, I'm using this tool and this is what I'm doing to limit the exposure to my employees. It's going to talk about what I have to do if I have dust that has become airborne. What housekeeping do I have to do? You know, can I open the window and let it blow around, or do I have to collect it some way? And then it's going to tell us what we need to do to restrict access of work areas when necessary to minimum the number of employees exposed to the silica. OSHA talks about only the people involved in that task should be in that task. So this is part of what your written exposure control plan is going to do. It's going to define this task of what I'm doing and who's involved and who should be involved and who shouldn't be involved. So the employer is going to have to review and evaluate the effectiveness of this written plan at least annually and update as necessary. So once you have your plan written, it doesn't mean that it's perfect, so you may have to change it and you may have to reassess it at least on an annual basis, but maybe job site by job site. But you have at least a written plan to follow to start. The employer shall make a written exposure control plan readily available for the examination and copying upon request to each employee, as well as the representatives from OSHA and NIOSH. So your written exposure control plan is going to be, again, per the piece of equipment, not the job site. So if you can't just write it up saying, I'm going to the job, I'm going to strip the floors, I'm going to paint the floors, and I'm going to be done. That's not a written exposure plan. You're going to say, I'm going to go to the job, and I'm going to use jackhammer to break up the concrete. That jackhammer needs to have a written exposure control plan. I'm going to use a handheld saw for mortar removal. That's going to have one. I'm going to use a floor milling machine. That's going to have one. Then I'm going to use a large grinder. That's going to have one. So each one of these has a different one, and each one has different requirements for respirator use. So each of your operators involved in that task have to follow that written exposure control plan for the task they're in, not for the task that somebody else might be doing right next to them. And they can't be in the same areas, so you're going to have to define the task. Be careful as well. This written exposure control plan might have to be informed. It's going to be your training guide for people that aren't even your employees. If they're trying to come into your task while you're working, you're going to have somebody pull that and say, hey, you can't be in here without this respiratory protection because we are doing this task and there's a hazard involved with it. So written exposure control plan is probably the #1 key element to get you in compliance, and it's also going to be able to be used for many other things. It's going to be your training for your employees. It's going to be your record keeping. It's going to be your benchmark to know what the plans are and if we are meeting what we're supposed to be meeting. So it's your benchmark to start to say this is what we're supposed to be doing, and we'll go from there. So when you have a written exposure control plan, you're also going to need a competent person. So the competent person is required to be provided for the control, to monitor the control plan, implement the control plan. So that job is to implement and monitor the written exposure control plan, to make regular inspections of job sites, materials, and equipment. It was defined at one of the OSHA meetings I went to one time that the competent person cannot be somebody sitting in a desk that did the job hundreds of miles away. It needs to be somebody who has firsthand knowledge of the equipment, of the tasks at hand, is within driving distance. So it can be somebody who's got a bunch of jobs going on in the same area, but they can't be out of town where it requires a plane to get back there to fix something that is in need of fixing. So the competent person must provide employee training to ensure compliance and exposure controls. They must ensure proper housekeeping practices and controls are in place, and they must keep accurate records for job site visits, air monitoring, and medical surveillance. So this is the person also that's going to keep the records. So if somebody comes to the job site and says, where's the records? Here they are. What are the requirements of a competent person? Well, a competent person is someone who can identify existing and foreseeable silica hazards, is authorized to promptly eliminate or minimize silica hazards, and has the knowledge and ability to implement the written exposure control plan. So I think that one right there in the middle is the most important. We already know this person knows the control plan. They can train people on it, but they're authorized to eliminate or minimize silica hazards. So basically what that means is if they see something in the control plan that's not working, they're authorized to make a change. They're authorized to change that on the fly to say, hey, this isn't working and we want to make a change. And that's what this competent person can do. So who is a good candidate for a competent person? Well, the employer can designate any of his or her employees to be a competent person if the employee is qualified, including the employee who does not work on the job site. So it doesn't have to be somebody that works on the job site, but it could be somebody that's working on the job site. But it has to be somebody who's qualified to understand this. The standard does not require specific training for a competent person. The employer is responsible for determining what training is necessary. So again, to become a competent person, you need to have the full understanding of what's going on, what the hazards are, each piece of equipment, what the control efforts are for each piece of equipment, and the ability to change that on the fly should you need to be able to change that on the fly. Let's talk a little bit about the housekeeping procedures because they've changed somewhat from the old practices. Everybody knows that picking up dust at the source is very important, but what do we do once we have picked it up and there's still dust left over? So the housekeeping requirements in a silica standard apply only when cleaning could contribute to the employee exposure of respirocrystalline silica. So they give an example in there that says if you're landscaping and digging a hole in the backyard, then you don't need to worry about housekeeping. They also give one that says if you have wood dust and you're cutting up plywood, housekeeping does not apply because you don't have Respiratory Silica. So if you have silica that become airborne that could harm somebody, that's when housekeeping applies. The employer shall not allow the use of dry sweeping or dry brushing to remove dust from areas contaminated with silica unless methods such as wet sweeping and HEPA-filtered vacuums are not feasible. So in the past, when you're grinding a floor and you have a large pile and people are coming around with brooms and they're sweeping it off the slab or they're sweeping it into a corner, that can't be done anymore. So we understand you need to keep, or they understand, you need to keep the grinder moving because that's your production tool. But the guys behind it that are picking up material between passes, they need to be using a HEPA-filtered vacuum. They no longer can use brooms. The employer shall not allow cleaning of surface or clothing with compressed air unless compressed air is used together with a ventilation system. If you're going to use compressed air to blow out a joint or blow out a hole, then make sure you have a vacuum system there that's collecting that smoke into a funnel while you're blowing it out. Same for clothing. If you're going to stand there and blow your clothing off at the end of the day, make sure you're going to a side draft booth that you're going to push all of that into a HEPA-filtered bank so it doesn't become airborne where other people walking by are going to be contaminated with that dust you just blew off your clothes. They do allow the use of a squeegee tool on the floor to pile dust is acceptable as long as no silica particles become airborne. You can have a squeegee tool pushing it around. You can't use it as a broom creating it airborne. So if you're just pushing a pile out of the way and it's not going to become airborne, that's permissible. Vacuum system must be equipped with HEPA filtration for interior cleaning. The vacuum system must also have a mechanism for cleaning the filter. Two new things required that weren't required in the past. If you're going to be doing housekeeping, it has to be HEPA filtered and it has to have a mechanical filter cleaning device. And be sure employees have been trained in required housekeeping procedures and that they understand how to use these engineered controls. That's important. Everybody needs training. Your compliance, your written exposure plan for each tool, I'm going to show you a sample in a little bit, that's going to define the training as well as a record for people to go back to. Medical surveillance. The employer who should make medical surveillance available at no cost to any employee who needs to use a respirator more than 30 days. The employer shall ensure that all medical examinations and procedures required by this section are performed by a licensed healthcare practitioner. The employer must obtain a written report of any examination within 30 days. The examination record also must be made available to the employee on request. And the exam must include medical and work history, physical exam, chest x-rays, pulmonary function test, and then TB tests on the initial exam only. So they define in the guide, in the small entity guide, exactly what needs to be done. They give you sample medical reports as well. So if you're needing one for your licensed healthcare practitioner, you can show them a sample of what OSHA is looking for, and just make sure that you have one of these for each and every one of your employees, as long as that employee is going to be wearing a respirator more than 30 days. If the employee is a driver that's going to and from the job site and he's going to be on the job here and there but not doing any of the tasks requiring respirators, then he does not need medical surveillance. It's for the guys that are doing the tasks that require respiratory use. So you'll see in a minute that Table 1 for a couple of the entries say if you're using this tool the way we're telling you to, you don't need any respirator use. Well, if that's how that person is doing and that's the only task that they're going to do, they don't need medical surveillance. But if they're going to have the possibility of doing another task, then that requires respirator use more than 4 hours and then, or more 30 days, excuse me, then you would find that they're going to need medical surveillance. The frequency of the exams, it's got to be within the first 30 days of the initial assignment. Remember that assignment that's requiring to wear a respirator for 30 days. And then it has to be every 3 years from the employee's last examination. Employee training. When we saw that chart earlier and it said the communication of hazards, well, this is communication of hazards. teaching the employees what's going on. So the employees must be trained at the time they were assigned to a position. Additional training must be provided as often as necessary to ensure employees know and understand respiratory silica hazards and the protection available in their workplace. The silica standard does not require the employer to use any particular method for training employees. There is no outline of how. They just want to make sure they're trained. The employer must make sure each employee is aware of the exposure to silica for each task or duty they are to perform. Again, that's why the written exposure control plan would be a great training mechanism for all of your employees, because for each task it changes. So you may have 5 tasks going on a job site. They need to be trained 5 different ways. That's the exposure plan for that piece of equipment. Keep it with it, and that's your training guide. The employer must ensure that each employee can demonstrate knowledge of the health hazards related to the exposure of silica. The employer must ensure that each employee can demonstrate knowledge for the engineering controls and practices in place to prevent exposure to silica for each task or duty they are required to perform. Again, written control exposure plan is going to give you the engineering controls and practices in place to prevent exposure to silica. The employer must make a copy of the respiratory crystalline silica standard available at no cost to each employee. So that's something you're going to want to have. If they ask, you have to give it to them. So let's talk a little bit about Table 1. We're going to go through a couple of quick examples here. The first one is handheld grinders for mortar removal. So if we look at the engineering and work practice control methods, it's going to say use a grinder equipped with commercially available shroud and dust collection system. It's going to say operate and maintain the tool in accordance with manufacturer's instructions to minimize dust emissions. You really want to look to the manufacturers of the tool, both the vacuum or the piece of equipment you're using, and use their recommendations because they know best. They've tried this. They know what's going to work for it and what's not going to. So you have to lean on the manufacturers to stay in compliance because they know as things change. You know, today this tool required this vacuum, but we made it that much better, so go out and get a different vacuum because now this tool requires this because it's creating more dust, whatever it may be. Dust collectors for handheld tools must provide 25 cubic feet of air, that's the CFM, or greater per inch of wheel diameter. So that's a big one. On the handheld tools, inch of wheel diameter is 25 cubic feet per inch of wheel diameter. The vacuums must also have the filter efficiency 99% or greater and a cyclonic pre-separator or filter cleaning mechanism. Now it's important to understand here 99% efficient. They don't state at what micron size, so you're going to want to make sure you're not getting a 99% efficient filter that's at like 100 micron because that means 1% of the dust going through is 100 micron and we know that that's hazardous. So you're going to want to make sure that even though they only defined it as 99%, make sure you're getting something 99% that is efficient. As far as a cyclonic pre-separator filter cleaning mechanism, know the difference between the two. Cyclonic pre-separators are fantastic tools. They reduce the dust that goes into the filter, but they don't eliminate it 100%. In fact, they act as a classifier almost. So if you do have a cyclonic pre-separator and you're using that to get the dust out of the airstream so it doesn't go into your shop vac or whatever vacuum you're using, make sure that shop vac or whatever you're using has excellent filtration because the dust that does escape a cyclonic pre-separator is all ultra fine. So that's the smokiest of the smoke, the finest of the fine dust because the separator took out so much, the vacuum's going to see even more ultra fines. Make sure your vacuum, if you are using a cyclonic separator, is going to have great filtration. Otherwise, you're going to be blowing the most hazardous dust back into the work environment and affecting people. And remember, this is the dust you can't see. So it's definitely, you want to make sure you have great filtration. Now we go over to the required respiratory protection. Well, if I'm going to be using this tool for less than 4 hours, I need an APF 10, standard type respirator. And if I'm going to be over 4 hours, I need an APF 25. These are going to be more complicated respirators. You're going to want to have a fit test done for your employees. You're going to want to prove they know how to use the respirators. It's required by the standard now, and make sure the cartridges are checked regularly and that they understand how to use the respirator, because just having a respirator hanging half over your face isn't protecting you. You need to make sure that respirator is being used properly. So let's look at walk-behind milling machines and floor grinders. This one says use machine equipped with integrated water delivery system that can continuously feed water to the cutting surface, and then it says operate and maintain tools in accordance with the manufacturer's instructions. Well, it's important to point out here that if you use water, if that's the decision that you want to take to use water, that you are responsible for that dust after it dries. So if you use slurry and that slurry dries, you are responsible so that slurry does not become airborne. So just putting water down to minimize airborne dust doesn't make your responsibility go away. It actually makes it a little harder because now you have a slurry you have to collect, and when the slurry dries, you're responsible for it. So if you're already off the job site and people are tracking the slurry all the way around, even outside of the task that you were doing, you've got to now go do housekeeping of that area and get it up. So water's tricky. Or you can use a machine equipped with a dust collection system recommended by the manufacturer. Operate and maintain a tool in accordance with the manufacturer's instructions to minimize dust. And that's going to be make sure your shrouds are properly sized, the skirt's properly put down, the hose size is the right size, the vacuum size is the right size, that you're not doing things to cause lack of vacuum from friction loss, like using 150 foot of vacuum hose, which is going to deliver far less vacuum than 25 feet of vacuum hose. So you've got to make sure you operate according to the way that it's designed to. The dust collector must provide an airflow recommended by the manufacturer or greater and have filter of 99% efficiency and a filter cleaning mechanism. Filter cleaning mechanisms, there's many varieties out there. Basically understand the reason for a filter cleaning mechanism is so your operators are not exposed to the dust in the filters. This was not written to sell a certain feature on somebody's piece of equipment. This is not written to mandate that your equipment's out of date if it doesn't have the newest bell and whistle. That's not what this is for. This is to ensure that the operators are not exposed to the dust that's in the filter. And if I've got to take the filter out and bang it against the wall, then all that fine dust that the filter just stopped is going to become airborne, and it's going to affect everybody not involved in the task, because the task happened over here and I'm out back banging the filter against the wall while I'm creating another area, and now I'm exposing people that are not involved in the task, and these people don't know that they're supposed to have respirators on and whatnot, and then they're going to pick it up and track it more. So make sure that your vacuums have a way to clean the filter from the outside of the machine. Now, some different standards of that. You can use mechanical devices, you can use pulse type devices, you can use vibrators, you can use motorized shakers, manual shakers, anything, so long that you're not exposing your operator to the dirty filter. When used indoors or an enclosed area, use a HEPA filtered vacuum to remove loose dust in between passes. So as I'm using this as a dust collector, I need a filter that's 99% or greater efficient. When I'm using it as a vacuum, I got to make sure I have a HEPA filter on there. So that's important to understand. If you're just going to use it as a dust collector, you don't need a HEPA filter, but if you are going to vacuum between passes, then you definitely need a HEPA filter as part of the housekeeping. Let's look at one of these written exposure control plans, because this is going to be a big part of the communications of hazards, the training, as well as your compliancy and your record keeping. So this is a sample one that was taken right out of OSHA's guide. We've changed it to a particular piece of equipment, but believe it or not, in here we didn't have to change much. So most of this is pre-written, and we just had to dial in exactly what was required for this task. So we're going by table 1, and we're saying, okay, the company is this, the person completing the plan is this. The description of tasks, this one is grinding and polishing concrete floors. Control description, the description controls. Well, we're going to use this particular grinder, 24-inch grinder and polisher, and we state the manufacturer and we state the model number, so it's no confusion on the job site that the operator can't take, the wrong piece of equipment and put it and pair it to it. So we name exactly what the equipment is, and we're going to say it's available with a commercially available shroud and a certain vacuum, and again we name the vacuum, and the vacuum is rated by the grinder and polish manufacturer, has a filter at least 99% efficient, and a filter cleaning mechanism. Has things that are supposed to have, the operators know this. Use a portable fan to exhaust air and prevent the buildup of dust. That's something that OSHA does permit. It's in there, so that's part of the control pan. The work practices. We're going to check the shrouds and hoses to make sure that they are not damaged before starting work. We're going to make sure the hoses do not become kinked or bent while working. We're going to clean the vacuum filter at a frequency recommended by the manufacturer. We're going to empty the vacuum as needed to prevent overfilling. You're going to use the grinder and polisher and vacuum control according to the manufacturer's instructions to release as little visible dust as possible. If visible dust increases, check controls. So we're defining what we're doing, and we're saying, hey, if things change, somebody stop and somebody go look at what's going on because something changed. Respiratory protection. Well, as per Table 1, we just looked at grinders. It said no respiratory protection is required when recommended vacuum equipment. When using recommended vacuum equipment. So basically, because it says none, our plan says we don't need to have it as per Table 1. Housekeeping. We know that dust-containing silica on work surfaces must be cleaned using a wet method or a HEPA-filtered vac. Do not use compressed air or dry sweeping for removing dust. And dispose of vacuum materials in a container to keep your container sealed. This one's huge. Dispose of vacuum materials in a container and keep containers sealed. Everybody is very confused. I mean, obviously there's people that are trying to use this standard to fear other people into purchasing a certain brand of equipment or a certain feature on a piece of equipment. It couldn't be the farthest from OSHA's requirement. OSHA's there to protect employees. They're not there to sell equipment. So there is no specific feature that you're going to have on your equipment. However, there are certain ways you have to treat your equipment and treat the dust. And this one is dispose of vacuum materials in a container and keep the container sealed. You can no longer take your vacuum, whether it be in a pan, a drum, whether it be a bag that you collected it in and you're pouring it out, or the bag ripped, you can no longer do that. Once you've collected this and you've taken all the efforts to collect it either from the equipment or from housekeeping, you need to make sure that that stays concealed in a concealed container. So later, when you throw that in the dumpster, you can no longer just pour it loose in the dumpster, because when the dumpster comes to get emptied 3 days later or 3 weeks later, and they pour that dumpster out, well, that silica is going to become airborne. It's going to affect people not in the task. It's going to transfer to another area where these people aren't even aware that silica is a hazard. So if you're using a drum or a pan or whatnot, make sure you put that into a bag, and make sure that bag is a high quality bag, because you don't want that ripping later on, especially when they toss it in. If you're using some of the continuous duty baggers, make sure that the bag on there is of high quality, because if you have bags that are prone to ripping and when you throw them in a dumpster they rip, you're now going to create airborne dust, and that's not allowed. So make sure you're containing this dust all the way away from the job site. That's very, very important, and that is written, those are OSHA's words, not anybody else's, and that is basically what they want to see in your written exposure control plan, so your operators know, hey, I can't just throw this stuff loose in the backyard or in the dumpster. And then it says, I have procedures used to restrict access to work areas. Scheduling the work so only employees who are engaged in the task, the grinder and polisher, and employees helping the operator are in the area. If others need to be in that area, they need to be trained of the hazards and wear the same respirators and do the same thing, even if they're not your employees. So the written exposure control plan, we just outlined everything for this particular task. Again, we have these all written for you for the equipment we provide, so it will outline to your employees what you need to do, what we need to do from an equipment standpoint, what the methods of compliance are, what the engineering control practices are, our housekeeping procedures, and also the procedures of keeping people out of our task. So, and then what is required for respiratory. Very, very great things to have on each and every job site for each and every piece of equipment, so there's no guesswork. Engineering controls. So let's just review these again. Dust collectors with the CFM reckoned by the manufacturer for specific equipment being operated. For hand grinders, the vacuum or dust collector must provide a minimum of 25 cubic feet per minute of air for every inch of wheel diameter. Dust collectors must have a filter with 99% or greater efficiency. Dust collector must be equipped with a filter cleaning mechanism, manual, automatic, or pulse to keep the filters clean. Remember, don't let the operators touch the filter to clean it. HEPA filtration is required for the interior use when vacuuming between passes in housekeeping. And then consult the manufacturer to be sure your dust collection system meet the new requirements for the task being performed. And you're going to want to review this on a regular basis. One of the things we're going to go back to real quick, dust collector must provide a minimum of 25 CFM. If you take a wheel diameter, 5-inch wheel diameter, I need 125 CFM. It was defined in OSHA that that vacuum must maintain that. You can't just buy something that has a number on the outside of the box and as soon as you plug it in, that CFM is reduced greatly and no longer have that. That's something that they want to see maintained, that 25 CFM. That's not a maximum number on the outside of a box. So when you're doing the task, make sure you oversize your vacuum for the task, because as the filter becomes a little bit more coated with dust, or the hoses get a little longer and there's friction loss, you want to make sure that you have plenty of suction for that tool so you don't see airborne dust. Here's just some samples of Ruwac controls with our 20,000 vacuums out there in the marketplace. We've been doing this in the concrete industry for 20 years. Even machines that are 20 years old are in full compliance of these new OSHA standards. All of our vacuums used as dust collectors start at 200 CFM. The vacuums are equipped with a microclean filter, which is 99.9% efficient at 0.5 microns. So they're looking for 99% at no declared micron size. We're 99.9% at 0.5 microns, which is just almost there at HEPA. So that's why you're going to get a filtration system that is near HEPA just when you're using it as a dust collector. And all vacuums are equipped with a manual filter shaker cleaning mechanism. Again, that's going back since we started. And you can add HEPA to any and all machines out there in the workplace. So let's talk a little bit about grinding without engineering controls. You'll take a look here on the left. You can barely see the guy because he's got so much dust. He may have a respirator on, but anybody else involved, he's in and around that task that's not knowing is going to be affected. Even after this dust settles and he leaves and the wind blows, they're going to be affected days later. So you want to capture the dust so it can't become airborne again later. Grinding stone without the controls on the other side, again, looks harmless. He's got a respirator on, but all that dust is blowing somewhere else. It's going to affect somebody somewhere. Here's grinding granite indoors. It's actually concrete, but polishing concrete indoors. Now we have dust collection on here. You'll see that as we move that collector around, there isn't going to be any airborne dust. Over to the right, we're using a handheld tool with a vacuum with a hose. He's actually using a handheld tool for other than mortar removal, which says under 4 hours he doesn't need any respiratory protection. He's just doing a small area, so he does not have respiratory protection on, nor is it required. Real quick, if they don't comply with Table 1, so we're going to talk about the alternative exposure assessment. Employers that conduct tasks not listed in Table 1 or do not fully and properly implement the engineering controls, work practices, and respiratory protection described in Table 1 of the specified exposure control methods approach must follow the alternative exposure control methods. Construction employees following alternative exposure control methods must assess an 8-hour time-weight average exposure for each employee who is or may reasonably be expected to be exposed to respirocrystalline silica at or above the action level of 25 micrograms per cubic meter in an 8-hour period. So again, I don't fall under Table 1, or I couldn't do all of the things that Table 1 said. Now I've got to take this alternative exposure, and I've got to make sure that each employee is going to fall, is going to be monitored, that he's not going to be affected by this. Respiratory protection. Employers who follow the specified controls methods listed in Table 1 must provide respiratory protection where required by Table 1. Clearly tells you APF 10, APF 25. Employers who follow alternative exposure control methods must provide respiratory protection. And this is where exposures exceed the PEL during periods necessary. So we're not saying less than 4 hours or greater than 4 hours when you take the alternative exposure control. We're saying, I've got dust, or I don't have dust, we need to have respiratory protection. Where exposures exceed the PEL during tasks, such as some maintenance and repair tasks for which the engineering and work practice controls are not feasible. During tasks in which each employer has implemented all feasible engineering and work practice controls, but exposures remain above. So just to summarize real quick, rule went into effect June 23rd, 2016. Employers must be in compliance by September 23rd, 2017. You must pick compliance option of Table 1 or the alternative exposure control method. Must have a written exposure control plan. Must designate a competent person to manage the plan. Designate housekeeping procedures and practices. Provide medical surveillance where required. Employee training program, very important. And HEPA vacuums for interior spaces. Just so you know, all of the information that we've given you today in this program has come from the Small Entity Compliance Guide, which is an overview of the full compliance guide, and you can find every resource to that there. There's also, if you go to OSHA.gov Silica, you're going to find a lot of resources there, including posters that you can see. And we definitely recommend you should have copies of this for you and your employees to review and understand. This has been an overview. I thank you for taking the time to listen.